Hi, this is Lakshmikant Tiwari, and first of all I welcome you that this is the very first video in NLP series. So in this lesson I'll be covering spam text message classification using NLP. So throughout our video series we will be using sklearn and Spacy libraries, but let's go ahead and first focus on in this lesson. So in this lesson first I'll cover introduction of the NLP, and then I'll talk about how we can what are the libraries which we can use for natural language processing like sklearn, Spacy and NLTK, and then I'll talk about how we can do these things, and then I'll talk about bag of words. This is one of the most the simplest word embedding techniques. So in this lesson we will be using bag of words, but from the next lesson onwards we will be using words to vector, because bag of words are one of the basic techniques, and for educational purpose and as a beginner you should know bag of word technique as well. Alright, after that I'll be getting started with the coding, a step-by-step coding where I'll be using this spam.tsp dataset, which is here, and it will be uploaded to my GitHub repository, from where you can download this working file and this TSV, which is a tab separated file. Okay. All right. So after that, I'll be telling you how you can balance your data set, and then I'll be showing you some exploratory data analysis. Then a data pre-processing will be done, and then finally pipelining and the random forest classifier will be built there, and then we will be also testing it with the SVM classifier as well, and then finally I'll be testing it with some particular I'll be testing it with the messages, with the real messages, whether the message is ham or spam. Let's go ahead and say here it says that it is ham. It says that it is ham, but if I say here you have won tickets, it says that this is a spam. You have won, let's say if I say here you have won free ticket, this says that is spam. If I say here you have got free tickets, it says that is spam. So there are so many things to learn in this lesson, but before that we start this lesson I should tell you that if you haven't watched my previous videos, you can go ahead at my channel KGP Talkie. I have been making so many videos on the data science. You can go ahead and watch my videos on the RNN, LSTM and Python basics, CNN, which is kind of deep learning, of course that is deep learning, and then scraping, web scraping, LinkedIn, and then the feature selections, classical machine learning algorithms, data visualizations. So there are so many, more than 30 hours free lectures are available at KGP Talkie, which you can watch. All right, so without wasting time, now let's go ahead and start this brand new lesson. All right, so the first question comes, what is NLP, or natural language processing? Natural language processing is a field of artificial intelligence concerns with the processing and understanding of a human language. Since its inception during the 1950s, machine understanding of language has played a vital role in translation, topic modeling, document indexing, information retrieval, and the extractions. Now let's go ahead and understand what are the applications of the NLP. The NLP can be used in so many areas. The few of those areas are like text classification, spam filters, voice text messaging, like conversion of audio to text, and sentiment analysis, spell or grammar check, like we have a Grammarly, Chatbot, search suggestion, search autocorrect, automatic review analysis system, machine translation like a Google Translation, and so much more. There are the wide variety of NLP application, and almost 45 to the 50% machine learning applications are currently, the data are being handled as a text data. So the moreover, along with the numerical data, there are so much the text data also available. available to process. So if we say that the classification of NLP we can do in two broad way. The broad way is speaking like text classification and the text generation. Alright, so natural language understanding is kind of the text classification where model understand the semantic or the sentiment of that text and then finally give the result. And natural language generation means where your model generates language, like in a chatbot. Chatbot generate a language, robot speaking robot generate a language. But sentiment analysis or text classification is kind of the understanding of that text. That means that is a text classification. Alright, so in a simple way, this is how we can introduce NLP in a layman language. Now let's go ahead and understand what is the process of natural language understanding or text classification. Let's say you have a raw speech signal or you have a sequence of words which is spoken or just you have in the form of the CSV file or in the normal variable. Then we need to do a syntactic analysis using the knowledge of the grammar. Alright, and one more thing before I go ahead in this lesson, I'll be covering the basics of the NLP from the next lesson onward. Since this is the very first lesson in the NLP series, so I'm just going to give you overall idea of the NLP and I'll be just doing an example very thoroughly. Alright, very quickly. So in this lesson, I'm not going to explain very deeply what is the syntactic or semantic or the pragmatic analysis, but from the next lesson onwards, I'll be covering these topics one by one. So the syntactic analysis is kind of grammar knowledge. I mean, what are the grammar of that word, which it presents at the past and in the future, and then what is the meaning of each word, like ran or run. If it is run, then it is kind of in present word, present tense, and if it is ran, then it is a past. All right, I mean the kind of the word, etc. verb, and then it is then it study about the structure of the sentence. That means semantic analysis using information about all those meaning of the words. And then it do the partial representation of meaning of the sentence. That is done by using pragmatic analysis, and this is kind of from where it starts generating the context of that sentence or a document, and then it finally reaches to the final representation or meaning of that sentence or a particular document. So this is how text classification is done. Now let's go ahead and take an example. For example, if I say I love Isu, all right, so I love Isu, and if we do the machine learning analysis on that sentence, so this is kind of I love Isu, and there I am showing some kind of the love to the person. And if I say that I hate dog, then that's mean this is kind of the negative sentence where hate is there. All right. Now, if I break down this sentence, Isu ate the apple, how a machine learning model break down this sentence to understand the semantics or the sentiment of this sentence? All right, and how a final representation will be done for this sentence. So the first sentence will be broken down into the two parts, noun phrase and the verb phrase. So this is the verb phrase and this is a noun phrase. And in the noun phrase, it find out that the issue is a proper noun. And in the verb phrase, it find out that there are one main verb and then there is a noun phrase. So it then again classify that main verb ate, and then finally noun phrase is classified into two classes, determiner and the noun, which is the apple. All right. So this is how our machine learning model starts classifying. Now let's go ahead and understand how natural language generation are done. For natural language generation and natural language prediction or classification, this is kind of a cycle. Okay, the way we do a natural language classification, in this just reverse way we do a natural language generation. All right. So it is kind of divided into 5 parts, like phonology, morphology, syntax, semantics, and then the reasoning. Reasoning is a final meaning. All right. Once again, let's say if I say I love issue, then a speech analysis of that particular phrase will be done, and then the final context or a final reasoning will be made. I mean, this is some kind of there is the positive sentence. And if in same way, let's say if I ask a chatbot to give me some positive sentence, or if I say a chatbot I love you, the chatbot also reply me I love you too. So for that, chatbot would understand that I need to reply something because that person love me, then I need to reply something so that he also love me. All right, in the same way. Otherwise, the chatbot also can reply I hate you, but I don't think the chatbot do those things. So in the same way, a reverse process will be done here. A first semantic will be found out, that a context, that's when there is kind of the love context, and then the syntax realization or syntactic realization would be done there, and then the morphological realization will be done, and then finally a speech synthesis or text generation will be done. So this is how kind of a cycle between natural language classification and generation. All right, now the question is how we can get started with the NLP. There are basically 3 main libraries which we will be using throughout this video series. Not 3, but in fact we will be just using these 2 libraries, sklearn and spaCy. All right, and we won't be using the NLTK, that is Natural Language Toolkit. NLTK have a lots of the disadvantage. This is kind of the very old library, but the spaCy is a kind of the new library, and this is a very optimized library, so we'll be using a spaCy. Although in this lesson we will be just using sklearn for a spam messages classification, because for a spaCy we need to understand first a lot of the basics of the natural language processing. That is why I'm not covering spaCy in this lesson, but I'll be covering spaCy from the next lesson onwards, because there is a lot of the introductory lesson need to be covered first before we cover spaCy. You can install scikit-learn by running this command in your Jupyter notebook. Otherwise, you can run just pip install scikit-learn in your Anaconda or a command prompt. Alright, and this is how you can install a spaCy. Since we are not using spaCy in this lesson, so I'm not going to install these 2. I have already installed scikit-learn library. Alright, so let's go ahead and understand what is the advantages and the disadvantages of spaCy and Natural Language Toolkit. spaCy is almost 400 times faster than NLTK. Although spaCy is a very new one, NLTK has been almost the 15 years in the market, but it is not optimized. spaCy is a state-of-the-art accuracy, but NLTK is kind of so-so accuracy. spaCy tokenizer maintains alignment, but here in NLTK the tokens do not maintain alignments to the original string. You might be getting confused with the tokenizer, because this is very new term for us in this lesson, but of course this is very old term in natural language processing. I'll be covering this tokenizers, part of speech, entity detection, dependency parsing, noun phrases, word to vector integration, and all those things I'll be covering from the next lesson onwards. All right, since in this lesson we will be not using these techniques, so I'm not gonna cover those techniques, but you need to just know that tokenization is kind of dividing these sentences into a particular token. Like if I divide this part of a speech tagging into a token, then I can say this is one token, this part is one token, and speech is another token, and this tagging is another, and off is another token. All right, perfect. So this is how this tokenization works. And then powerful and concise API, not too much confusing APIs. And then it is integrated word vectors. So it has integrated word vectors. That's mean word to vectors we can do with this spaCy directly. But there is just only disadvantage in spaCy. It is available only for an English language at present, but I think the currently Spacy is available for a lot of the lots of other languages as well, not just for just not for the English. Let me see. Spacy is available for it's available for English, German, French, Spanish, Portugal. There are so many languages are available. All right, so Spacy is available. This image is kind of the older image. That is why it is written there. It is available for English, but Spacy is available for all these languages. All right. And you can now you can see here how Spacy is well maintained that. All right, so we are going to remove NLTK completely. We will be not using NLTK until and unless it is most important to use in our video series, in our further video series. All right, perfect. Now let's go ahead and see for what purposes we use these library. So these are the purposes for which we use these library, like tokenizing, part of speech tagging, and entity detections. Entity detection is kind of very interesting. For example, let's say if I say Apple is opening a new opening a new factory. All right. So if I say Apple is opening a new factory, then Apple is a organization or a company entity. All right. But if I say here issue at the Apple is not organization here. All right. Apple is a fruit here. So this is how we do entity detection, and then dependency parsing, and then noun phrases, word to vector integration, context derivation. That's mean a final context. What is the context of that document or a sentence? All right. Perfect. And so much more. There are so much more. So there is going to be so many video series, so many videos in this video series. So you just keep watching. I'll be covering everything in this video series. Now, what are the data cleaning options available, and which we can do actually with these libraries, like case normalization. Why case normalization? If I say this issue at the Apple, here A is small, and if I make A capital, then by default this is two word. By default this is one word, but if we do the brute force classification, then Apple with a small a and Apple with a capital A would be Apple with the small and the capital would be the two word there. But if I do if I do a lowercase normalization, then the all uppercase will be normalized to a lowercase, removing a stop words like and, the, punctuation, etc. So these are the most widely used word, and that doesn't convey much information in the text classification. And the limitations are stemming of word. I'll be covering these very details in the next lesson onwards, but let me tell you what is the limitation. Let's say if I say ran and run. All right. So what is the base form of that verb run? All right. So limitation or stemming brings variation of a word into a root form. Like if I say run and runs, cat and the cats. So cat and the cats is just a cat there. All right. So with this way it compress the information. Limitation and stemming compress the information. And then the part of speech tagging makes a sense in a grammatical way. Entity detection tells what is the particular meaning of a word. I mean, which is it belongs with the organization, geography, or some kind of fruits, all those things. And then finally we do the bag of words or word to vector. So in this lesson we will be using bag of words. This is the one of the simplest techniques, word embedding techniques, and I promise you I'll be covering word to vector as well in our further lessons, but in this lesson I'll be limiting this video to just bag of words. Now let's go ahead and see what will be covered in this video series. In this video series, introduction of NLP and spam detection using sklearn will be covered, And after that we'll be doing reading text and the PDF files in a Python. Then we'll be doing tokenization, part of speech tagging, word to vectors, and bag of words in this lesson. And then the real world practical examples like movie review, recommendation systems, the Twitter semantic analysis, sentiment analysis, or a Facebook post sentiment analysis, or LinkedIn post sentiment analysis. So we'll be doing all those things, or a sentiment from an image, text, etc. So these we will be doing in this video series. But in this particular lesson, I'll be covering introduction of NLP and spam detection using a sklearn library. Now let's go ahead and understand what is a bag of words. This is one of the simplest word embedding techniques in natural language processing. And let's say if we have here these three documents, but one thing before I discuss bag of words in detail, I should tell you that this is not often used in practice due to its oversimplification of the language and sparsity of the matrix generated by bag of words. But for educational purpose and for a classroom settings or for this video setting, this is really very necessary to start with the bag of words. At least you should know what is the bag of words, although you will not be using a bag of words, because in the further lessons we will be using word to vector techniques. Now let's go ahead and see if we have these these three documents. Document 1 says that I am high, document 2 says that yes I am high, and the document 3 says that oh I am kidding. All right, so truly I tell you I'm not high. Maybe I'm high, who knows. Okay, so these are the three documents, and in these three documents how the bag of word works. The first, it counts the word, all the words, unique words, and then it find out that how many times this word has occurred in a particular and the documents. All right, so let's say in this doc 1 I occurred just one time, am occurred one time, and here high occurred just one time, but s and the kidding does not occur, that is why it is 0. But in the doc 2 you see I occurred one time, you see here I am occurred one time, and high is one time, s is one time, but kidding does not occur. In the document 3 I occurred one, m, and then kidding, and these high and the s does not occur. So let's say if you have a large documents, then in that case there would be a lot of the word, then there would be a lot of columns there, and that is where a bag of words creates a problem. So it is not all, it is not guaranteed that all the words will occur at least a single time in all the sentences in all the documents. Mostly then the matrix generated by this bag of words are a sparse matrix. Do you know the sparse matrix means if matrix have most of the 0, the values in a matrix if mostly are a 0, then that matrix are sparse matrix, and that is not good because it takes a lot of the memory without giving much information. So that is where we use vector to word. It compresses all the information together, which we will be covering in our further lessons. All right, so what we are going to do, we are going to use this bag of words with the techniques of TF and IDF. And we will be using sklearn TF IDF. You can go ahead and get this link here. And in this link, it says that it uses L2 normalization and IDF. The IDF is kind of the full form. You see here term frequency. A term frequency means how many times a particular word has occurred in a document, and the inverse document frequency is kind of how many times a particular word occurs in whole the documents, and then inverse of that actually. This is what this, we are doing here inverse document frequency, because let's say if a particular word occurs most of the time, all right, a major time, because punctuation and stop words like and, the, therefore, a, these occurs most of the time. So these should not give most importance while classification. That is why we do the inverse document frequency. So it penalizes most frequency occurred word, and it gives it gives importance to rarely occurring words. So this is really very very important algorithm, TF-IDF, term frequency times inverse document frequency. Now let's go ahead and see with this example here. So with this the figure. So with this figure you see here, I had taken this from the Google. The TF-IDF is a measure of originality of a word by comparing the number of times a word appears in a document with the number of doc the word appears in. Okay. So you see here, it is kind of the log. All right. So TF-IDF is kind of log 1 plus total number of documents. In this case, total number of messages divided by 1 plus the document frequency of the term. I mean, how many times that word has occurred in that particular documents or in that particular message, and then plus 1. So in our case, we have almost more than 5,000 messages. So you can say the 1 plus 5,000 divided by 1 plus, and how many times for a particular word has occurred, and then plus 1. So this is kind of how it works. All right. So you might not use also plus 1. So that doesn't actually, this is just a constant. So it does not add much information in machine learning. All right. So this is how we introduce natural language processing. Now let's go ahead and get started with NLP. The first of all, we need to load NumPy as NP, pandas as PD, matplotlib.pyplot as PLT. Let's go ahead and run this in our Jupyter notebook. So it might take a little time to load these libraries first time in your computer. And if you don't have a NumPy, pandas and the matplotlib, you can go ahead and watch my previous videos. I have covered NumPy, pandas and matplotlib in very deep. And I have I already have this spam.tsv file you see here. So it has here a number of messages, and this is the first one is a label which says that which message is legitimate, that is ham, otherwise if message is spam. And then the next column is message, and then it has a length and how many punctuations are there. So it says that for a first message there are total 29 word, and there are 6 punctuations are used in the first message. All right. So TSV is a the tab separated file. All right. So this file I had downloaded from Kaggle, although I'll be uploading this file to my GitHub repository, and the link will be given into this video description. You can download this file and this working Jupyter notebook as well to work along with me. All right, so let's go ahead and load this in from pandas.read CSV. Load this into a data frame df, and it says that spam.tsv, and there I'm going to say that the separator which I'm going to use in this case is tab separator. All right, so let's go ahead and see the head of this df. The head of df says that it has a label, and label says that the ham is legitimate message, and there is a spam. So you see here a third message is spam, and if you read here a third message, the third message is here, this is spam, and very clearly you can see here it says that the free entry in 2 weekly competition to win FA Cup final, etc., etc. And you might be getting a lot of the messages in your mobile as well. So this kind of the messages is mostly a spam. All right. So this is how it is saying that this is a spam, and the length of that message is 155 word. All right. 155 word or it is character. Perhaps this is word. I don't think it has 155 word. This is, I think, 155 characters total. All right. So this is the character length perhaps. Yes, that is character length. All right. So is it character length? Yes, that is character length. All right. So you see here it has just 30 character length and 1 punctuation. All right. So this is a character length and this is total the punctuation. How many punctuations are there? All right. So let's go ahead and see if there is any null values. I don't think there is any null value. So you can just say is null. It will give you a complete data frame. And if you want a sum of this data frame, just write there a sum. It says that there is no null values present into this data. Let's go ahead and see how many the data samples are there. So there are total 5,572 data samples, or 5,572 messages are there. Alright, so let's go ahead and see how many spam messages and ham messages are there, and that we can get ahead with the df label and then value underscore counts. So this says that 4,825 messages are legitimate message, which is ham message, and 747 messages are spam messages. Alright, so with this we say that we see here one thing, that this data is highly skewed data and unbalanced data. And the unbalanced data means this data is not good for actually classification in machine learning. Otherwise our model will be tend to ham or to classify a legitimate messaging. So what we need to do first, we need to first balance this data. Alright, so we need to first balance this data. To balance this data we need to also take just 747 messages for in our legitimate category, because if this message, if this the data is not balanced, then we won't be getting a good accuracy. All right, perfect. Now let's go ahead and first get ham messages. So ham messages we can get with the df, and then the df with the label, get all the label which has ham. And let's go ahead and see the head of ham. You see here we have got ham messages, and similarly we can get spam messages as well. So that we get with the df, and then here we have a label is equal to spam. So it will, what it will do, it will iterate over the rows of all the rows of this data frame and compare. If the label matches this spam, then it will take that whole row in that particular data frame. All right, perfect. So we have got ham and spam. All right, now let's go ahead and combine this ham and spam together by calling here the append method. So with the append method we can say here data is equal to ham dot append. This is going to append these data frame spam, and then I'm gonna also ignore the indexes, that is the true. Alright, so let's go ahead and see the head of this data. So I am appending this spam in ham, that is why we are getting first ham. And if I say here a tail, because this spam is appended in the last of the ham, we should get here spam, and we got spam. Alright, but if you see here this index is not reset, just it is ignored. To reset that index, what we can do here, we can say here data is equal to data dot reset index, there should be in place is equal to true. No, it's not true. Okay, let me see how we can do this. Okay, no problems, we don't need this one, so it's okay. So we have here now, oh sorry, this is just a spam and ham. What I did here, actually I had just appended, I should not append it now. Okay, what we need to do here, first I need to first get the data shape of ham and spam. All right, so you see here the ham shape of ham dataset is 4825, but spam dataset size is just 747. Now what we need to do, we need to select randomly 747 messages only from this legitimate messaging data frame. And to do that, what we need to do here, we need to just call here ham dot sample. It will select randomly spam dot shape and then 0. All right, so with this we have got here ham, and if I say here, and if I see now shape of this ham, it is just 747 rows there. All right, now we have ham, and just copy this and paste it here. Now we have ham and spam in the same size, and now this is a perfectly balanced data set. Now let's go ahead and append this into a data. Now this is how this has been appended into a data, and here we have total 1493 indexes, and this is reset indexed. All right, perfect. So we have our data now. Now we need to do some exploratory analysis for our data. Why I am doing here exploratory data analysis? Because you see here a length and the punctuation is into a digit, I mean a numerical value. Let's go ahead and see how these spam and labels are varying. All right, so let's go ahead and first plot here. First do plt dot hist. I'm going to do a histogram here for a data, and inside the data I'm going to take a label first. The first one which I'm going to plot a label where it should match a ham. All right, and then I'm also going to provide total length. All right, so this is how histogram takes input x. So it has here x and the y, and then total bins for this I'm gonna provide 100, and alpha I'm gonna provide 0.7. So let's go ahead and plot this. It gives you a lot of the numbers, so let's go ahead and show plt.show. Now you see this is a histogram plot for a ham messages, and this says that the number of character presents in that particular message. All right, ham kind of messages. So ham are legitimate messages. Mostly messages are having values somewhere around 30 or 20 or 40, perhaps it is somewhere around that. So it is mostly concentrated, or most of the messages are number of messages, number of characters in legitimate messages are less than 100. All right, but if I plot here, let's go ahead and copy this and paste it here, and we need to just change it to a spam. And if we plot a spam as well together in the same histogram, we see for a spam messages, the most of the messages in a spam category have large number of characters. So this is kind of this can be a kind of important information while classifying a particular message, as a spam or legitimate message. All right. Perfect. Now what we are going to do here, now similarly I am going to plot punctuation for a punctuation. All right, so this is I have plotted for character length, but now I am going to plot this for a punctuation. So let's go ahead and plot this for a punctuation, and in the punctuation we don't get much information. I mean, in a punctuation, spam and the legitimate messages are having kind of a same punctuation histogram, so that doesn't include much information while classifying a particular message as a spam or a legitimate message. All right, so this is all about data pre-processing. Now data exploratory analysis and the data preparation. Now now we are going to do a data preparation. All right, so data preparation. All right, so this is how we are going to do the preparation. The first of all, we need to import libraries from a sklearn, necessary libraries like a train, test, split, so that we can they split our data set. So here we have from sklearn dot model selection import train, test, split from sklearn dot in symbol, and then here I'm gonna import a random forest classifier, and then here the from sklearn dot svm import svc, and then from sklearn dot metrics we will be evaluating our models in the form of accuracy score and classification report and confusion metrics, and then finally from sklearn dot pipeline import pipeline. I'll tell you why we need a pipeline. So this is how these are the libraries we will be using. The library we are forgetting about, a TF-ID vectorizer. You know the TF-ID I told you during the introduction. So this is a TF-IDF. So we need a TF-IDF vectorizer so that we can utilize bag of word in a scikit-learn. So that we can get from sklearn dot feature extraction dot text import a TF-ID vectorizer. All right, so we have got TF-ID vectorizer. Now let's go ahead and see the data once again. With the data dot head we have got the data. Now we are going to do a train and test split, which we can do x underscore train and then x underscore test. Then here we have y train, and then finally y test is equal to train test split. There we need to pass first x data. That x data is message. All right, and then we need to pass here y data, where y data is level, and then we need to pass here a test size. The test size is 30%. That's mean the training will be done into 70% of the data. And then here we have a random state is equal to 0, and then here we have shuffle is equal to true. All right, and then finally we have here stratify is equal to the data label. Let me tell you why I am using this shuffle. The shuffle because I had added spam over ham data frame. A shuffle will make sure that ham and the spam are shuffled together in a random way, and stratify will make sure that ham and the spam is divided into training and the testing in this 30 and the 70%, 70 and 30% proportion. All right, so now let's go ahead and see x underscore train. So the very first message, it seems that this is a spam. Let's go ahead and check with y train, and yes, the y train says that the very first message was a spam. Perfect. So we have got our x train and the y train. Now this is the time we can do vectorizer, or we can do a bag of word creation. All right, so the bag of word will be done with the vectorizer. So here we have a vector, or you can say just it is vectorizer is equal to tfid vectorizer, and this tfid vectorizer, in this I'm going to do first the vectorizer on x train. All right, so for x train, what we can do, x underscore train is equal to vectorizer dot fit underscore transform x underscore train. All right, now let's go ahead and see a shape of this x train. Now you see the x train shape has changed. It has 1045 number of rows, and it has 3708 columns. So this 3708 columns, if you remember my previous example, it says that there are 3708 word in that particular document, total document, and these are the messages. That means there are total, how many messages are there? There are total 1045 messages are into a training data set, and there are 3708 unique words are into this x train. And if we check this x underscore train, you will see here that scikit-learn is so smart that it has stored all these elements in a compressed sparse row format. Okay, so there are total how many elements? So there are total, these number of elements are stored into a compressed row format. All right, and otherwise it is mostly a sparse matrix, because if you multiply this 1045 and multiplied by 3708, it says that this is kind of a very big matrix, but they are just 17,938 the elements in those messages. All right, perfect. So we have got here our x train. Now this is time we need to utilize our random forest classifier along with the pipeline. So this is where I'm going to use a pipeline. I'll tell you why we are using a pipeline and random forest classifier. The pipeline, because there would be a lot of the the repeated processing for training and the testing data set separately. That is why I am going to use a pipeline here, because if I do here a vectorizer for a train and the same time but after the training the model, I need to also do for a testing x test as well. But this will make sure that it should do vectorizer while vectorization while classification. All right. So here in a CLF is equal to a pipeline. Pipeline means there would be some sequence of operations which will be executed one by another, which we will define here. So in a pipeline, this would be kind of a list there. So the very first time a list of tuples there, and the very first time I'm going to say that I'm going to do a TF-IDF. Okay, and then in the TF-IDF I'm going to first call here TF-IDF vectorizer, and then in the another tuple, then for another tuple I am going to say the name of that as a CLF, and I'm going to call here random forest classifier, and in that number of estimators I'm going to pass here 100. All right, and n is equal to n jobs. I'm going to pass -1, which will make sure that use all available cores in my computer. All right, perfect. So this is how we have created a pipeline. Now if I call here clf.fit, and if I pass here x_train and then y_train, what it will do actually, it says that lower is not found. Actually what happens, x_train is already converted, so I can just call this x_train. Then now I'm not going to run this because it will be converted and updated. Now I am going to pass here just directly this. I'm going to run this now. Yes, it has trained the model and it has fit the model, and these are the default parameters which is used while fitting this model or a spam messages training data set. And you see here, if you press shift and the double tab, a detailed documentation will come. Sorry, for this TF-IDF vectorizer actually I wanted to show you. You see here the TF vectorizer, shift and the double tab. There are so much things in the TF vectorizer which we are using a default setting, like stop words. We are not using a stop word since this is just a very introductory lesson, and I'm just going to use very the default stop words. There is no, and the token parameters. So this is kind of, it is just getting words. Okay, a simple words which will be just a made token. A simple word will be splitted by just using just spaces, and the normalization range in between one argument there. Max DF is 1, minimum DF is 1 also, and max feature is none. So there are so much the setting which we are using here by default. All right, at least in this lesson. Perfect. So this model is already fitted. Now let's go ahead and do the prediction. y_pred is equal to clf.predict. Now you see here, this is where this pipeline is important. Now during the prediction, we actually don't need to process our X test data set separately. Now we need to do here just X_test, it will automatically process. We have got here ypred. Let's go ahead and show here a confusion matrix, and in that we have here y_test and then finally ypred. Confusion matrix says that this is a true value and this is a predicted value, and this is legitimate messages and this is spam messages. So it says that this is a true value. So this says that there are 225 messages where you see, you add this, there were legitimate messages in which two legitimate message was classified as a spam message, and you see here this one is spam message, and and this is predicted as legitimate message, and 198 spam messages were predicted correctly. Now let's go ahead and see the accuracy for this, which we can do with the classification report. The print classification report, there we need to pass here y test and then y spread. Alright, so if we pass here y test and the y spread, we get almost 94% of the accuracy. And similarly, if we call here accuracy score, there we pass y test and then y spread, we get the 93.76 accuracy, or around 94% of the accuracy for classification. Alright, now let's go ahead and predict a real message whether and see whether it will classify it into a spam or a ham. Let's say I see the predict clf.predict. I'm gonna say hi, this is Lakshmikant. So this says that this is legitimate message. All right, let's say if I say hey, what's up, this says that this is legitimate message. All right, so let's go ahead and create some a message which looks kind of a spam message, like we are offering some kind of free tickets, etc. So let's say if I say here, congratulations, you have won a free ticket to the USA this summer. Text, let's say 1 2 4 4 5 5 and 6. Let's go ahead and test this one. So very clearly it is saying that this message is a spam message, and definitely it looks like a spam message. There are so many keywords like free tickets, text 1 to this one. So these are the kind of the identifiers which predicts that okay, this message is going to be a spam message. And similarly you can predict other messages as well, like let's say if I delete this text 1, perhaps then it will not classify this as a spam. Still it is saying that this is a spam. And if I delete this congratulations, so let's say if it says that spam, yes, still it is saying that a spam. All right, so if I remove this free, then see here, now it is saying that this is a legitimate message. All right, so this is how it is working. So this is way we have classified it with random forest classifier. Now we are going to classify it using SVM classifier. So what I am going to do here, I am going to just copy this and this, all these things, and then again I am going to paste it. Just press V in your keyboard, you will get that. So here we have pipeline and SVM. Actually we should get here SVM. Now here for SVM, what we need to do here, actually we need to just replace this with the SVM, and there I'm gonna pass here a C value. By default C value is 1. I'll tell you why we need to do why we need to increase the C value, I mean penalty. Now here we have auto. All right, perfect. So let's go ahead and run this. It says that SVM is not defined. Actually this should be the SVC. All right, perfect. So it has classified this. Now in a confusion matrix, you see everything is classified as a spam because here we are not using a penalty. Let's go ahead and use this penalty as a 10, then see what happens. Now you see still it is classifying all the messages as a spam. Let's go ahead and make that 100. Now you see here the accuracy has increased. Now this accuracy is 93%. So similarly, I'm going to make this 2000C, and let's go ahead and classify this. So with this I get 94% accuracy, and if I make it 1000, alright, so I still get 94% accuracy. And here the accuracy score is 94.2%. So this is kind of better than a random forest classifier. Yes, so hey, what's up? It predicted as a ham message or legitimate message, but this SVM classifier has predicted this: you have won tickets to the USA this summer as a spam message. And if I say you have won instead of, if I say you have got instead of you have won, now this says that this is a legitimate message. Alright, so this is all about in this lesson. Thank you so much for watching this video. Please do not forget to like and subscribe this channel so that you can get updates directly into your inbox. Bye bye. Have a nice day.